Hi, I am Muhammad Abdul Shakur, and this is my Lab 3 presentation for Physics 2211. Lab 3 is split into two parts. Part 1 focuses on simulating a star orbiting a black hole and estimating the black hole's mass. Part 2 analyzes whether the force on the star always points towards the black hole using vector direction checks. In Part 1, the objective was to simulate the motion of a star orbiting a black hole using Glowscript. We use a unique seed, my Georgia Tech ID, to generate a custom elliptical orbit and calculate momentum, force, and the black hole's mass. This function generates an elliptical orbit by calculating x and y positions using cosine and sine. It simulates a star sweeping equal areas in equal time, consistent with Kepler's second law. In the simulation loop, I calculated initial and final momentum vectors, the computed and the net force using Newton's second law. I split the net force into components, parallel and perpendicular to the direction of motion. Here you can see the simulation in action. At the center is the black hole, shown as a large black sphere. Surrounding it is a red ring, a visual representation of the danger zone or event horizon. If the star ever crossed this boundary, it would collapse inward. The green trail shows the orbit of the star as it moves under gravitational influence. Even though the star isn't visible, the motion is clear through the path it leaves behind. I used the gravitational formula to isolate and estimate the black hole's mass. The calculated mass stayed consistently close to the actual mass of the Sun. In Part 2, the goal was to investigate whether the net force on the orbiting star always points directly towards the black hole. This checks whether the force truly behaves a central gravitational force. I calculated the angle between the force vector and the position vector from the star to the black hole. When the angle is so close to 0 degrees, it confirms the force points inward, which matches real gravitational behavior. Here's the result for Lab 3, Part 2. What if the net force didn't always point towards the black hole? Then the orbit would break. The star could spiral away or fall in. What does it mean that it does? It confirms that the force is truly gravitational and central as expected. And if the black hole's mass were wrong, the orbit wouldn't match the motion, proving the math matters. To summarize, in Part 1, I successfully simulated a realistic star orbit and estimated the mass of the black hole. In Part 2, I confirmed that the net force always pointed towards the center, verifying it was gravitation. This lab deepened my understanding of orbital dynamics and real-world motion modeling. Thank you. Like, share, and subscribe.